know if they'll turn out good. So the first thing I'm going to do is add or subtract to get those y's together. You see that there's y's on the left and y's on the right? That's a problem. And I like to add or subtract to get those gathered up. So I choose the smaller of the two to move so that I end up with a positive y term. So I would draw my river down the middle. I'm going to minus 4y. If you did it differently, it's okay. Don't erase yours or scribble yours out. You might have just did yours in a different order, and that's fine. So now I have 7/5 still, nothing plus nothing, because this was a zero pair, equals 4y minus 1/5. So far, so good? Now it's nice because there's only y terms on one side or the other. So now we can use Cole's idea to get rid of the fraction and multiply. If we wanted to, we could multiply through by 5. Or since I noticed that both of these have the same denominator, I'm going to go ahead and just add the 1/5 to each side right now. And I'll get rid of the fraction in a minute. The fractions don't bug me so much when they're the same denominator. But if you hated it, you could multiply everything by 5 earlier. So now I've got 8/5. My river is curvy. 8/5 on the left, and on the right, 4y. And now I am going to do what he did, and that is to multiply each side by that denominator. So I've got 5 here, so I'm going to multiply by 5/1. I got to do it on both sides to be fair. If I would have chosen to multiply by 5 all the way up here, that's fine too, but I have to multiply all 3. Do you see that there's 3 terms here? 7/5, 4y, and negative 1/5. If I chose to multiply by 5 up there, I have to multiply all 3 terms by 5. Down here, there's only one thing on each side, so I'm good. But if you choose to multiply early, make sure that every term is multiplied by the same number. So here I've got 40 divided by 5, which is 8. And here I've got 4y times 5, which is 20y. Have I lost you? Okay, if I have. Then divide by 20 because I want to have the y alone, and right now it's 20 times y. So divide by 20 on each side. So I got y equals 8/20. But typing in that will get it wrong. It needs to be simplified. And I noticed that 8 and 20 both have a common factor. 2 will work. I thought of another one, but this works too, because now I've got 4 and 10. So it just has 2 again. You could have said 4, but it doesn't matter. We would all still end up with the same exact thing. So 2/5 is the magic number that when I put it here and here both, I'm not going to do it right now, but if I use 0.4, if you want to use a calculator to check quickly, 7/5 plus 4 times 0.4 equals 8 times 0.4 minus 1/5. And sure enough, you should each side should equal the same thing. That's what solving equations is you're looking for the magical number, which you could guess all day. It's just not efficient. This definitely works every time. I know it takes a lot of steps, but guessing, it would take longer.
Did you do one of those?
Yes. How about this one? Yeah. This is a nasty one.
This looks like one
it looks nasty, but actually it's not. It's bad. But yes, let's do one more fraction. Or do you want me to do the one that's on your screen?
Sure.
I can do that. Is it?
It's only got one fraction. But
Okay, maybe we'll do both. We'll do both because fractions are just frustrating. I wish, you know what else is frustrating is these markers don't work very well. Okay, what is it?
5/16 minus 14 equals 1.
Okay. What's the plan?
Plus 14.
Okay. plus 14. So I got 5, 6, t. That's a zero pair. Here's my river, and it equals 15. Okay, okay. So looking at what we've been doing each time, I'm saying, what do you think should be next? Multiply by 6. I like it, because we're going to try to bust that fraction, get that fraction so that it's not a fraction anymore. So then we're 30 over 6 would be our new fraction over here. And so that would be just 5. So 5t, you can think of canceling out those 6's, equals 15 times 6. 6 is at 90. Because we 3 sets of 30. And then last thing to do is we realize 5 times t and divide by 5. And so t equals whatever that is. 18. Did you try it? Did it work?
It was actually a quiz, so after
It's right. Got it right. And if we wanted to check, another thing, again, we could do is put 18 up in here. 18 times 5 and divide by 6. Subtract 14 and see if it equals 1 before you would put submit normally. All right, one more fractioning one. Let's do this one as long as it's up here. And you know you're going to see something with a bunch of fractions. What do we do when there's a bunch of fractions? Stay calm. Is that what you're going to say?
Same.
Yeah, same. We could get them all to have the same denominator first, or we could think about what would that denominator be and multiply everything by it. That's what I would recommend. So we've got 3s, 15s, and 5s. What's going to be the best 15? Because 3 and 5 is already 15. 3 times 5 would be 15. 15 is already 15. So I would, every single term in here. So why don't you take a second and write this down so you have a nice model of what it looks like. If I can make it bigger. So it's 4/3 plus 2/3 x equals 44/15 plus 7/5 x plus 4/5. And so what we're going to do is multiply every single term, all 1 term, 2, 3, 4, 5 terms. Each one of them we're going to multiply by 15 over 1. We can't just pick and choose ones we feel like doing it with. We have to do it with all of them. So the way I show it on my work is just go through and squeeze it in. 15 over 1. It doesn't matter if it's on the left or right, but if every single term's got to get multiplied by 15 over 1. And then you can go ahead and multiply the numerators and the denominators if you want. We've been doing that a lot now, so maybe we're ready for a shortcut here. 15 times 4 is going to be 60, divided by 3 is going to be 20. Another way to do that is to think of 15 divided by 3 is 5. 5 times 4 is 20. So this whole thing becomes 20. Plus, here I would have 15 times 2 in the numerator, which is 30. 30 divided by 3 is 10. And the x is just coming along. It's all multiplication, so the x is still just multiplied by it. Okay, pause for a second. Have I lost you on those first 2 terms? I don't know what 44 times 15 is, but I'm going to multiply 44 times 15 and then divide by 15. So I know I'll be back at 44. You can figure that out if you want to see what 44 times 15 is, and then divide by 15 if you want. But 15, you could also think of this 15 and this 15 canceling or equaling 1. Plus, 7 times 15, I don't know that off the top of my head, but then I'm going to divide by 5. 15 divided by 5 is 3, so this term is going to be 21x. Again, what I'm thinking of here is 15 divided by 5. 15 divided by 5 is a nice even 3. 3 times 7 is 21. And then plus, here, same kind of idea, 15 divided by 5 is 3. 3 times 4 is 12. Another way to do it would be to say 4 times 15 is 60. 60 divided by 5 is 12. Whew, that looks so much better. That red line is like solvable. I could do this. This was like, oh my God. This is just like, okay, it's all right. I'm going to go ahead and combine the 44 and the 12. Combine those like terms. I just feel like I've got a little broom and I'm just tidying this whole equation up until it's doable. So here's the river. I haven't messed with the left side anymore now. 20 plus 10x. Those are not like terms. 44 and 12 is 56, right? Plus 21x. All right, so now I'm to the point where I've got x's on both sides of the equation, but I wish I didn't. I did 44, because those are just ones with no x, and 12, because those are just ones with no x. 44, 54, 55, 56. I think I'm good. Okay, so now I want to move the x's all to one side. I've got 10 of them over here, and I've got 21 of them over here. So to move things, we add or subtract. So I'm going to subtract 10x. You can think of it as trying to make a zero pair. I want to eliminate the x's from one side or the other. Might as well eliminate the littler one. So this is we call it a zero pair. 10x, I took away 10x, now there's nothing there. So now I've got 20 on the left and 56 plus 11x on the right. Still with me? Okay. Got all my x's over here. Now I want all these little ones to be on the other side. I want to eliminate the 56. It's a positive 56, so I'm going to subtract 56, which means I'm going to have negatives, but we can handle it. So 11x is left over on that side, and 20 minus 56 is negative 36. Oh, I think I was going to mention on these, like they don't always end up being nice answers, do they? That makes me so nervous typing them in. I think I got it wrong. Then it's just, that's a gross answer. It is. Finally, 11 times x, so I need to divide each side by 11. And that's my final answer. Nothing more, because 36 and 11 don't have any common factors. I can't simplify it. So I just have to type in negative 3611. But before I push submit, I would make sure that my negative sign really showed up. But that one was gross. Okay, good job. We've almost been here for an hour. I think we should take a break and clear the fractions cobwebs from our minds. And then we'll come back and do the next thing. Okay, let's take like 10 minutes.